The second part of section 10.2 is all about simplifying using rational exponents. So that means we need to recall our rules of exponents. And I'm just going to go over a few of them and sort of the basics of it. So here in number 3b, we have x to the power of negative 1/2. So the first thing we have to do is we have to remember what a negative exponent does. And the negative exponent takes whatever you're raising to the negative exponent, and it sort of takes the reciprocal of it, or another way you can think of it is it puts that term in the denominator of a fraction. So for instance, the negative here, it changes it into x to the power of now positive 1/2. There's nothing else that we can simplify. If our directions were to write this using a radical expression, then we would go ahead and change it to a radical, but our directions for this are only to simplify, so that's as far as we can go. Now we can apply that same process when we have a lot more going on. Here we have 3x to the fourth, y to the power of negative 1/3. Between each of these terms, the 3, the x to the fourth, and then the y to the power of negative 1/3, we're multiplying. So we can treat each of these things separately. The only thing being raised to the negative exponent is the y. So I'm going to keep my 3, I'm going to keep my x to the fourth power, and that y now becomes 1 over y to the power of 1/3. And last but not least, we would want to write this as one really, really big fraction, so we want to remember our properties of fractions. When we're multiplying fractions, we multiply straight across. So our numerator is 3x to the power of 4 over the denominator of y to the power of 1/3. We can go ahead and take this and do even more with it. Okay, so we have 2xy to the power of negative 2 over x cubed, all raised to the power of 2. And this is really just your properties of exponents. There's no fractions in our exponents. So we just want to recall, what does this mean? When we're raising all of this to a power, it basically says to distribute the power to the numerator and the denominator of the fraction. So I'm going to take 2xy to the power of negative 2, and I'm going to give that an exponent of 2, and then I'm going to take x cubed and give that a power of 2 as well. Then from there, when we have exponents, when we have a product raised to exponents, we can distribute the exponent on the outside to each of our terms, each part of our product. So we're going to have 2 squared times x squared times y to the power of negative 2 squared. And then we have this here on the bottom, which is the same thing. So I'm just going to do all of the same properties at the same time. Okay, next, 2 squared, that's nice and simple. 2 squared is 4. X squared, that's also nice and simple. That's just x squared. And then when we're raising a power to a power, just like we are here in the denominator, we can multiply the exponents together. So this becomes y to the power of negative 4, and here we have over x to the power of 6. Now the last thing we want to do is we want all of our exponents to only be shown once, and we want all of our exponents to only be, all of our variables to only be shown once, and all of our exponents to be represented as a positive exponent. So the first thing I'm going to do is I'm going to deal with this here. X to the power of 2 over x to the power of 6. Our official property of exponents says that when we're dividing fractions, we can take this and say, okay, the top exponent minus the bottom exponent. So that would become x to the power of negative 4, which is really just an x in the denominator, an x to the fourth power in the denominator. Then if we look at our y to the power of negative 4, right, the negative takes it and puts it into the denominator as well. So we're simplified as 4 over x to the power of 4, y to the power of 4. So we have a lot going on. We need to recall a lot of information from our previous class. Now what you can also do is you can also simplify this first, simplify the x's first, take care of the negative exponent first, and then apply the outer exponent. So there's sort of a lot of different ways that we could do this. If we had done that, let's just go ahead and start that over. Let's say we work with our x's first and we work with our negative exponent first, right? Another way to do this, instead of using x to the power of 1 minus 3, is we can say, okay, well, where do we have more x's? We have more x's on the bottom of the fraction. How many more x's on the bottom of the fraction do we have? We have 2 more x's. So that means we're going to keep 2 x's on the bottom of a fraction. There's not going to be any more on the top of a fraction. The 2 is going to stay there because it doesn't have anything that's being done to it. All of this is, by the way, in our parentheses. And then we have our y to the power of negative 2. Remember, the negative in the exponent takes it and puts it onto the bottom of the fraction. So I'm going to take that and put that onto the bottom of the fraction. And that actually becomes a lot simpler. We already have a single x variable, a single y variable. All we have in the numerator is a 2. So again, we can apply our same process of distributing the exponent to the numerator and the denominator. And then simplifying. Here by just taking 2 squared. Here by giving the exponent of 2 to each of our terms. So x squared squared, y squared squared. I need to move up a little more. 4 over x to the 4th, y to the 4th. And again, either one of these, where are we? Here we go. Either one of these options, ignore that, there, let's straighten out my papers. Either one of these options is going to give you the exact same answer, see? But it just depends on what you see first, right? You have to be comfortable and know your properties of exponents for this. So let's go ahead and try this last one, which again just deals with our properties of exponents. We have x to the power of 3/2 times x to the power of negative 1/2 over x to the power of negative 2/3. So there's a few different ways that you can start with this. One way is you can start by taking all of your negative exponents and putting them in the appropriate place to make them positive. That would consist of moving this term to the denominator, moving this term to the numerator. Another option is you could just go ahead and apply your properties of exponents to multiply these two together and then eventually divide. I'm just going to be very straightforward and multiply these together. So our property of exponent says that when we're multiplying the bases together, we can simply add the exponents together. So this becomes x to the power of 3/2 plus a negative 1/2. So here in our numerator, that basically is 3/2 minus 1/2. So that becomes x to the power of 2/2, which is just x to the power of 1. So that's actually kind of nice here. So that whole numerator is just an x. We keep our denominator of negative 2/3. Then we can go ahead and apply our properties of exponents, saying that if we're dividing the bases, we can take that and subtract the exponents. X to the power of 1 minus a negative 2/3. Well, minus a negative becomes plus a positive. When we're adding fractions together, we need common denominators, so this becomes 3/3 plus 2/3. And that gives us x to the power of 5/3. And that's totally simplified. So we have a lot of different options for this, and it can be very confusing, but if you know your properties of exponents and you recognize how to use them, right, it just takes practice to get there. But once you know how to do those things, then it becomes much simpler.